In this video, we are going to prove the residual formula. Let f of z be analytic inside and on a closed curve C, except at the pole of order M inside C, that is a closed region. Then prove that the analytic function f of z has a residual at a given point by this expression here, which is the expression of the residual formula. So we are to prove this formula, and to prove this formula, let me change this ink. To prove this formula, we'll have to take a bearing from our Lorentz series, Run expansion, let's call it expansion rather, of f of z. So from our Lorentz expansion of f of z, we have f of z to be equal to a0 plus a1 into z minus a plus a2 into z minus a all squared plus plus a minus 1 into z minus a raised to the power of minus 1 plus a minus 2 into z minus a raised to the power of minus 2 plus plus a minus m into z minus a raised to the power of minus m. So the next step, what we are going to do is we are going to multiply both sides. Multiply both sides by z minus a raised to the power of m. Multiply both sides by this. That means we are multiplying f of z and the whole of this by this. So if we do that, we are going to have z minus a raised to the power of m multiplying f of z to be equal to a0 into z minus a raised to the power of m plus a1 into z minus a raised to the power of 1 plus, now let's do it, or let's break it down first of all. Z minus a raised to the power of m plus a2 into z minus a raised to the power of 2 multiplying z minus a raised to the power of m plus plus a subscript minus 1 into z minus a raised to the power of minus 1 multiplying z minus a raised to the power of m plus stop it at that. Now this is what we have. If we can still simplify this further, we are going to have z minus a raised to the power of m f of z to be equal to a0 multiplying z minus a raised to the power of m plus a1 into z minus a raised to the power of 1 plus m. This is from our law of indices. The same base, you add up the powers. This plus a2 into z minus a raised to the power of 2 plus m, it could be m plus 2 or 2 plus m, either ways, and this plus so that is what we have there. So from here, let's differentiate both sides. Differentiate both sides by m minus 1. Differentiate both sides by m minus 1 and take the limit, as z turns to a. So that's what we are going to do. Now if we do that, we are going to have limit as z turns to a of the m minus 1 all over the z raised to the power of m minus 1 into z minus a raised to the power of m f of z. This is at the left hand side. So at the right hand side, this will be equal to m minus 1 factorial a minus 1. This factorial here, it's factorial a minus 1. Now let me take that up here. Now from here, what we are going to do is we are going to make a minus 1 subject to the formula. A minus 1 now will be equal to 1 all over, let me write this like this, equal to limit as z turns to a of the m minus 1 all over, this is m, all over the 0th power of m minus 1 multiply 1 all over m minus 1 factorial into z minus a raised power of m f of z. And if we compare this with this, we discover that they are the same. So this is how to prove the residual formula. Please like this video and share with your friends. Subscribe to this YouTube channel, and also don't forget to click the notification bell to get notified each time we upload a video. Thank you.